Hello, in this video I will be going over the second law of thermodynamics and entropy and the Gibbs free energy equations and how to derive them. So first we will go over the second law of thermodynamics. And entropy. So an important thing to note is throughout these equations, I will say S, capital S, is entropy. So the first major equation is that the change in entropy of the universe equals the change in entropy of a system plus the change in entropy of the surroundings. And this can further be simplified to the heat of the system divided by temperature plus the heat of surroundings divided by temperature. And in an isothermal reversible equation, we have that the reversible heat equals in RT, which R is gas constant, times the natural log of V2 over V1. And that is important to know up here. So essentially the heat into surroundings must equal the heat lost by surroundings. And what this would mean is that the Q of the system equals the negative Q of surroundings. So from this, from up here, if we bring it down, we would essentially have the change in entropy of the universe equals RT natural log V2 over V1 over T minus RT natural log V2 over V1 over T is 0. And this equation is also assuming it's for 1 mole. And if it's irreversible, sorry. This is for if it's reversible. This is for it's irreversible. And we'd have the change in entropy of the universe equals RT natural log V2 over V1 all over T would be greater than 0. So essentially taking this equation and this equation, we can come to the conclusion of the second law of thermodynamics, which is the change in entropy of the universe, which is the change in entropy of system plus the change in entropy of its surroundings must be greater than or equal to 0. And this is the second law. So now we will go over Gibbs free energy. So Gibbs free energy to get Gibbs free energy, we will first start off with our general change in entropy of the universe equals change in entropy of the system plus change in entropy of the surroundings. Now the entropy change for the surroundings is delta S surroundings equal to delta H of the system over T, and delta H is the change in heat. That is what we will, this is the variable that we will use for change in heat. So now, bringing this equation and this simplified part together, we have change in entropy of the universe equals change in entropy of system plus delta H of system all over T. So now if we multiply all of this by T and -1, and one thing to note is that the delta S of surroundings is negative. We will have negative T delta S universe equals delta H of system minus T times change in entropy of system. So now what this side is delta G. So now we have delta G equals delta H of system minus T delta S of system. And that is the Gibbs free equation. So I will pan back and forth. This is how you derive the second law of thermodynamics and entropy equations to get them, and the Gibbs free energy equation.